So in the last video, I'd used some code that I found on one of the forums that would draw a diagonal line, and I've used that to make a triangle. So now I've removed that code that I found on the forums, and I've just got my triangle class, and I've got a option where I want the triangle to draw itself. So if I just run this now, it's not really going to do anything. All it does, it gets to the bottom, it creates that triangle as a set of data points and updates it. It does draw the thing, but I've got nothing in that draw routine, and I'm probably not going to use that draw routine in this video. But what I have found when I've been looking for ways to draw a filled triangle, I found this really interesting article on sunshine2k.de website. I'll link to that in the description. But it just goes through the standard algorithms for drawing triangles, and it's interesting that the easiest way to do it, and this actually looks really simple code, is to draw a triangle with a flat bottom. And if you remember, I've got that option to do like a scan line, so that's really what I'm going to be using. That's the only draw function that I've got built into MicroPython. This basically scans that down to a flat bottom, and then there's a reverse of it that does a flat top as well, that counts the other way and draws it the other way. Then the interesting thing is you can then draw any triangle by chopping them in two, because if you have one triangle, however it is on the screen, you can chop that through this center line, and that will give you a flat top and a flat bottom triangle. But anyway, that's getting a bit in depth for me today. There's other ways to do it as well. This is a complex way of doing it, but I'm going to go for the simplest thing today, which is this fill bottom flat triangle. I've actually downloaded this code from this site, and this is Java code here, and it's got fill bottom flat triangle. So I'm going to grab this and I'm going to try and convert it into MicroPython, because as far as I can see, this should work. I've copied that. Let's go back into Thunny. I'm going to create a new procedure here, and I'm going to just paste it directly in. So it's coming like this, protected void. We don't need that for this. I'm going to grab that def and put it there. So there you've got this defined as this fill bottom flat triangle. Now it looks like on this one they send the graphics function into it. It's a bit like sending the display into it. I'm not going to do that, and the vertices really are the same as the points. So I'm actually going to say we're going to send into that v1, v2 and v3, and if you look down here, these v's have got an x and y as well, so we're used to that. So we don't have to put the typing in Python, but I do have to put a colon after it. Now before I do anything else, I'm going to get rid of these braces because we don't want to use those either. Maybe let's sort the indentation out. Now I think if I run this straight away, it's not going to work because you don't have to define your type straight away in Python. So as you do in Java, it's saying this is a float. You see, this slope one is a float, but actually the calculation here, whatever that comes out, whatever type that calculation comes out, automatically gets added into this. So I'm going to just get rid of the float on the front of these variables. Okay, and that's saying that 0.5 is a float as well. I'm going to get rid of that f because I think I can just put 0.5 there. While I'm here, let's get rid of the semicolons because I don't necessarily need those either. All right, what we've got next then? Well, there is a float here, and this is a cast. So this is making sure this value comes out of a float. Now, in MicroPython, this is its own function. So if I just get rid of those brackets, I say whatever's inside of there, make it a float. So that's quite easy to just change there. We get into a point now where the code should run without erroring, although we've still got to fix this one. We've got to do the same thing with this int here. So we've got to make that x1 an int. That's a bit the other way around. So let's put the x1 inside it and get rid of that bracket outside. Do the same one with that one. So we're forcing those two to be integers, whatever the value is, because, well, I'm going to say draw line. It's not draw line. It's the thing that we send into the display has to have ints. So let's sort this out as well. This is going to be display, and then I think it's pixel span, isn't it? Pixel span. All right, so that's looking okay. Now the only thing is, on my point class, the X and Y are capitals. Wish I hadn't done that now, but anyway, so I need to change these X and Y's here. Well, I don't know what will happen if we run this. Let's try and run it and see what happens. Syntax error, line 41. Oh, that's it does the syntax first. I'm going to come back to this. Well, let's do it now. So this has got to be a range, hasn't it? We've got to change this to a range to get rid of this. So I don't think we need this plus, and in fact I don't think we need the brackets, do we, if I recall correctly? So let's get rid of the brackets, but we do need a colon. Get rid of the int as well. So we're going to say for scan line, and then we say in range, and then that range is in brackets. So the range is going to be this first value here to this second value, I think, or it will be that second value plus 1, something like that. But anyway, that's the range between those two, and it automatically assumes that it's going to add 1 to it. So I think that's what we need for there. So let's try and run this again. All right, so that's validated, because we're not calling this yet, but that's validated, so we've got the syntax right. But the other thing is we need to make these X and Y's capitals, because each of these V, I know we call this a point and we call it P in the triangle, but if we call this separately, it doesn't actually matter if we send these point objects in. They're just called V1s there, but by the time we get in this, it knows it's a point. So let's change that to those to X's, those to Y's, and then I've got to do the same there for the X's and the same there for the Y's. Those are all right, and those are all right because they're not referring to the values within the point. So if you see what this is doing, really, it's dividing one point against another to find the slope of both of them, and that slope is the amount it increments for each scan line, and that's so slope 1 is one side of the triangle, slope 2 is the other side of the triangle, and then it scans through these scan lines and draws a line between them. So now this is the last thing we've got to fix, because so we don't need the second Y. We see the temptation is to do it like that, but of course that isn't the length, is it? That's the point of where it is on the triangle. So I think what we have to do is take the one away from the other. So if I copy that there and put that there, minus, that should give me the length of the line, because it's one X point on the Y line to another one. So that should have got that pixel span to work. So let's stop and save this and run it. And at the moment we've just got this triangle. So the triangle starts somewhere in the middle on the top. It comes down here, goes across flat to on the 110 line, and then goes back up. So hopefully if I call this fill bottom flat triangle now, it will draw the triangle. So I think I'm going to cheat here for this video. I'm not going to do this within the triangle algorithm. I'm going to just do it outside. So just to test it. So fill bottom flat triangle, and let's take these points here and pass them into it. I mean, the best way for me to do this would be to alter this fill bottom flat triangle, to alter that so it accepted a triangle object. Then I wouldn't have to send these points in. But because I'm drawing two triangles, I might want to draw the top triangle and the bottom triangle at a later date. I'm just going to send the points in here for the testing. So let's save that, stop it, run it, and see what goes wrong. Okay, I'll see what the problem is. I've got these the wrong way around, so I'm drawing a minus value line, I think. So that should be x2 and that should be x1. Okay, there you go. So there's my triangle. There's my flat bottom triangle. If I wanted to make it more like the triangle, the double triangle I did in the other one, I can just alter the coordinates now, alter each of the points. So if I started off as 0, 0 on the top, I'll try that to start with. That should change it, yeah. So That's moved it across to there. So obviously when I get the other algorithm, that is the drawing the bottom flat triangle, I can put that underneath and get that one working as well. So that's the beginning of my filled in triangle routine. Hope you enjoyed that bit of the video. A little bit different, trying to port some code from somewhere else, trying to convert Java code back into Python code here, or MicroPython code. Again, if you look at this, you can really see what it's doing. It's quite simple. It's just building it up a line at a line. And of course, one of the things that you can always do is if you put a update at the end of a line in the loop, you can actually even see the way it builds it up. You wouldn't want to do this in some working code because it slows it down too much. But hopefully if I do it that way, you can see it starts from the top and builds it up line by line. And that's how it builds that triangle. So that's triangles, filled triangles. And as you see, very different from that previous code to just draw a diagonal line. Not saying that wasn't useful, but this is just another option for triangles.